today we're talking about least common multiple. The least common multiple is the smallest of a set of numbers common multiples. So this is going to help us a lot when we compare and order fractions and when we add and subtract fractions next week. So let's find the LCM of 8 and 14. The first method we're going to use is the list method. So I need to list multiples of 8, and I'm going to start with the smallest multiple of 8, which is 8. The smallest multiple of any number is the number itself. And then we skip count. So 8, 16, 24, 32, and I want to list the first 3 or 4 multiples of the number and then go to the next number that I'm looking for multiples for and list a few of those, because my list of multiples is infinite. So if I just keep going and going and going with my list, I could have done that unnecessarily. So let's look at 14. So skip count by 14s. 14, 28, 42. And when you're looking to add 14 bigger numbers like this and make a list, think about adding in parts. So add 10, which is 52, and 4 more, which makes 56. I didn't find a multiple they have in common yet, so I need to go back and add to my list of 8. So after 32 is 40, 48, 56, and now I can see that the smallest multiple that 14 and 8 have in common is 56, so that must be the LCM. The least common multiple for 8 and 14 is 56. We're going to use the prime factorization method now. So I'm going to find the LCM of 30, 50, and 75. I'm going to start with the prime factorization of 30, and I did my factor tree. No matter how you start your factor tree, with whichever factor pair, I could have started with 3 and 10 like I did, or 2 and 15, or 5 and 6. And either way, I should end up with the same prime factorization of 30, that 30 equals 2 times 3 times 5. And then I did the prime factorization for 50 and the prime factorization for 75, and I found each prime factorization. Now to find the least common multiple from the prime factorizations, I'm going to look for the greatest number of times each of the prime factors appears. So my smallest prime factor I'm looking at is 2. The greatest number of times it appears in any of these prime factorizations is once. So I'm going to use 1, 2. Then I see 3. The greatest number of times a 3 appears in a prime factorization is once. So I'm going to use 1, 3. The next prime factor is 5. 5 appears once in the prime factorization of 30. But it appears twice in the prime factorization of 50 and twice again in the prime factorization of 75. So the greatest number of times that the 5 appears in the prime factorization of these numbers is twice. So I'm going to bring down 2 5s. Then I multiply 2 times 3, which is 6, times 5, which is 30, and 30 times 5 is 150. So then my LCM for 30, 50, and 75 is 150. The third method we're going to use for least common multiple is the cake method. And it looks like a layered cake when we're done. That's why we call it the cake method. So I'm going to set up 18 and 8 inside my first layer. And I need to think of a common factor of 18 and 8. It doesn't matter what common factor you've used. It can be any common factor. So I'm going to do 2 because I recognize that they're both even. So 2 goes into 18 9 times, and 2 goes into 8 4 times. Then I see that 4 and 9 don't share any common factors. So my layers to my cake are finished. To find the greatest common factor, which we did last week, we would draw our G right here and multiply what's inside the G. This time, we're going to turn this cake layer into an L and multiply what's inside my L. So 2 times 9 is 2 times 9 is 18. And 18 times 4 Good. 72. So then 72 would be my LCM. Not so bad, right? So let's try the next one. I need the LCM of 27 and 45. So I'm going to put 27 and 45 inside my cake layer. 3 is a quick factor that I recognize. So I'm going to put 3 on the outside. 3 goes into 27 9 times, and it goes into 45 15 times. Good. So then I'm going to add my layer. And 9 and 15 are both divisible by 3. So I'm going to put 3 on the outside. 3 goes into 9 3 times, and 3 goes into 15 5 times. Now 3 and 5 don't have any common factors except for 1. So since they have no common factors except for 1, I'm done with my cake layer. So again, to find the GCF, I would multiply what's on this left side. But instead, I'm going to find the LCM. So I'm going to turn the outside portion into an L and multiply what's inside that L. So 3 times 3 is 9. 9 times 3 is 27. And 27 times 5 is 135. Excellent. And 135 would be your least common multiple of 27 and 45. And that's your cake method.